Okay, so we're going to work through some more examples of balancing equations. And I would suggest that you be writing these down as we work through them so that you can practice seeing what they should look like. I think it'll help tremendously if you can see it and write it out at the same time. So we're going to use my new little document camera here, and I'm going to write them out, and you can write them along with me. So first thing I want to do is to make sure that we're clear on subscripts and coefficients. So if I write, so here I've written Ca, which hopefully you're recognizing that that's an element from the periodic table. It's calcium. And then that little number is a 2. That little number is your subscript. So if it helps to write that down, you can write subscript off to the side. And then I'm going to use a different color so that you can see the difference. But this red, I'm going to put a 2 in front. And that 2 in the front is your coefficient. And that just kind of can help you identify what's what. And then I'll just go ahead and write element. That way you know what each part is, okay? So let's set up an equation. So over here, I'm going to go ahead and write reactants. So we remember that the reactants go on the right or the left. And then we always have an arrow, which is our yield sign. And then we have our products on the right. Okay. All right, so here is the first one that we will be doing. So I'm going to start off with, let's do this one. Na plus O2 yields Na2O. So I have sodium over here and oxygen here, and then sodium and oxygen as well on both sides. So what you'll want to do first is identify how many of each element we have on both sides. So how I do this is I write Na equals O equals, and then I draw a line down the middle where the arrow is to show that I'm looking at the other side now. So I have my reactants over here and my products over here. So I have my Na and my O. All right, so if I have Na here, I don't have any little number. So remember, that's the subscript. I don't have a number here. So anytime there's not a small number, that means it is 1. So I would have 1 of the sodium on the left. And then I have oxygen here. And I have my little 2. So that little 2 is indicating to me that I have 2 oxygens. And then on my right side, on my products, I have my Na with a little 2. So I would have 2 sodiums. And then again, there's no little subscript here. There's no number. So that always means that it's a 1. So it's 1. So looking at this, the way that I can tell if it's balanced is if I have the same number of atoms on each side for each element. So it should be the same number on both sides across this line. So I have 1 sodium, 2 sodiums. Is that balanced? No. Oxygen 2, oxygen 1. Is that balanced? No. Okay. So we can go into balancing these, but I'm going to save that for the end. So if people want to watch the end and practice doing that, then we could practice doing that. But for now, I just want to do some more examples of just pulling out how many of each element there is. So I'm going to do another one. I'm going to move this up. And here's our next one. I have, let's do P4, so that's phosphorus. Plus 3 O2, so that's 3 oxygens. We'll get back to how we do this in just a second. Yields P4O6. Okay, so let's see how many I have of each. So I have phosphorus, oxygen. I'm going to draw my line down the middle where the arrow is to show that I'm splitting up the two sides. Okay. So how many phosphoruses do I have? I have a little number 4 here. So that would mean that I have 4 phosphorus. Now here's the coefficient. So the big number again is the coefficient, and that's going to get distributed to this oxygen. So this little 2 is already showing me that I have 2 oxygens. So I need to multiply this 3 by this 2. So 3 times 2 gives me 6 oxygens. Then I come over to my products and I have a P4, so I still have 4 phosphorus. And then I have an O with a little 6. So that means I have 6 oxygens. So when I look at this, let's see if it's balanced. I have 4 phosphorus on my left on my reactants, and I have 4 phosphoruses on my right, which is my products. So that is balanced. And then I have 6 oxygens on my left and 6 oxygens on my right. So that too is balanced. So this equation has already been balanced. So it's showing that it's equal on both sides. Okay, let's do another. I'm going to scoot this up. All right. So we'll do this one. We have C for carbon plus H2 yields makes CH4. All right, so I'm going to put my C here and my H. I'm going to draw my line down the middle, do my C and my H. Okay, so how many carbons do I have on my left, on my reactant side? There's no number, which always means it's 1. I have my H2, so I have 2 hydrogens. Then I go to my product side. I have my C here. There's no number next to it, so that means I have 1. And then my H4, I have my little 4 here, so that means I have 4 hydrogens. Okay, so I'm going to take a second to actually work through this one with you. So we should be able to see right off that this is not balanced, right? I have a C1 and a C1, which is balanced, but I have a 2 for hydrogen and a 4 for hydrogen, so that's not balanced. So I want to get some more hydrogens over here to make that up. I have 2 here, I have 4 here, so I want to get more over here. So to do that, that's where the coefficients come in place. That's where those bigger numbers in front come in place. So I have a C, so my C's are already lined up, so I don't have to do anything to those. But my hydrogen, I want to get this to be 4. So to do that, I have to use a coefficient. So I need to think about what times 2, because I already have 2 hydrogen. So what times 2 is going to give me 4 hydrogens? And the answer would be 2. So if I put 2, the coefficient of 2 in front, I'm going to multiply that by 2. And so now I have a new number of 4. So now C1, C1, is that balanced? Yes. And then I have H4, H4, is that balanced? Okay. So I'm going to really quickly do one more thing to show you, and then hopefully if you have any other questions, you can let me know. So let me move this out of my way, and I'm going to put this down here just so we can practice labeling what's what. So this is asking you to label the product, the reactants, the subscript, the coefficient, and then the yield sign. So we're going to work through this. You can write this out and be able to label it just like this. But this is just a great way to be able to identify what's what in the equation. So this arrow is pointing to the actual, this side of the equation. So it's pointing to the left side of the equation. So these 2 items here on the left are going to be known as your reactants. That arrow in the middle, that's your yield sign. So it's kind of like your equals, or that's what's made. So that's your yield sign. So then we have our reactants here, our yield sign. So this would have to be our products over here. So that's what we end up with. So we start with our reactants, yield, a reaction takes place, and then the products are made. And then the smaller number is your subscript. And then the larger number in front, again, is your coefficient. Okay, so that is how you will be able to identify the different parts of that equation as well. You will get some more practice with this, and then if you have any questions, let me know. The only thing you really have to be able to do at this point, like I said, is just be able to pull out the different number of atoms for each one, and just tell me if it's balanced or not. I'm not going to test you over being able to balance them yourself. Maybe I'll add like a bonus question on the test to where you can try to balance it, and if you get it right, you can get the bonus point, but it won't hurt you. But the goal is for you to understand how to pull out how many atoms are there, and then understand whether or not it's balanced. And so that's kind of showing you that law of conservation of mass, showing you that matter cannot be created or destroyed, that it can be changed, but it's not going to be created or destroyed. It can just change into something else, like a gas, when it's released in a chemical reaction. So let me know if you have any questions, and I'll be happy to answer them.